Python Scipy stats Pareto fit. How does it work? Help and online documentation say the function scipy.stats.pareto.fit takes as variables the dataset to be fitted, and optionally b, the exponent, LOC, scale. The result comes as triplet, exponent, LOC, scale. Generating data from the same distribution should result in the fit finding the parameters used for generating the data, e.g., using the Python 3 console. Encode lines below leaving out the Python console prompt. However, this results in exponent 1 should be 1.5 and results in exponent 1 should be 1.1 and exponent should be 4, LOC should be 2, scale should be 0.4, in etc. Giving another exponent when calling the fit function. Returns always exactly this exponent. The obvious question would be, do I misunderstand the purpose of this fit function completely? Is it used somehow differently, or is it simply broken? A remark, before someone mentions that dedicated functions like those given on Aaron Clauset's web pages, this URL, are more reliable than the scipy.stats methods and should be used instead. That may be true, but they are also very time consuming and do for datasets of 10,000 points take many hours, maybe days, weeks, years, on a normal PC. Edit. Oh, the parameter of the fit function is not the exponent of the distribution but exponent -1, but this does not change the above issue.
It looks like you must supply a guess for the lock and scale. And the guess has to be pretty accurate for the fit to succeed. Hopefully the context of the problem will inform you what an appropriate guess for the lock and scale should be. Most likely, lock equals 0 and scale equals 1.
The fit method is a very general and simple method that does optimize.fmin on the non-negative likelihood function, self.nnlf, for the distribution. In distributions like Pareto, which have parameters that can create undefined regions, the general method doesn't work. In particular, the general NNLF method returns INF when the value of the random variable doesn't fit into domain of validity of the distribution. The fmin optimizer doesn't play well with this objective function unless you have guessed the starting value very closely to the ultimate fit. In general, the .fit method needs to use a constrained optimizer for distributions where there are limits on the domain of applicability of the PDF.
The problem is also that the variance of a Pareto distribution is not defined for C is lower than 2.
If you want to support the channel, please consider liking and subscribing.